Welcome at Johnny's desk. Today I want to talk about the topic no one wants to talk about. Overcurrent protection. I think you have seen one of these before. A lab power supply with voltage limit and current limit. Here we can set a current limit, 1 ampere, and the power supply will never supply more than 1 ampere. Now the question is, how could we implement a current limit in our own projects? I think you know what this is. This is a fuse. It protects your circuit from overcurrent. And here we have another type of fuse. It can be resetted and used again. Here you can see the datasheet of a linear voltage regulator. It has a fixed current limit which protects your circuit. But sometimes you rather want to set your current limit. So how can you do this? For regulating the current efficiently, we have to use an SMPS, a switch mode power supply, or a DC to DC converter. This is a high voltage capacitor charger. It uses the Flyback topology and a dedicated IC. The UC3842 has onboard current limit in form of a peak current mode control. Now you get a quick overview how a flyback converter works. A flyback converter is a type of power supply that consists of one transistor, a coupled inductor, an output diode, an output capacitor, and the load. In the on state, current flows through the transistor and through the coupled inductor, and a magnetic field is building up. When the transistor stops conducting, there is energy stored in the coupled inductor. During the off state, current flows through the output diode into the output capacitor. There, energy is supplied to the load. The output voltage is controlled by duty cycle, but also the current could be controlled by duty cycle. You might be wondering why I use the capacitor charger as an example. But, as you might know, a capacitor is like a short circuit when it's empty, and so the current must be regulated. Now let's talk about peak current mode control, since it's the easiest way to control the maximum current in a PWM converter. Here we have the primary inductor, this one. Let's measure the current. Here we can see that the maximum is at 40 amperes. The current is measured by this shunt resistor. This voltage is proportional to the current, and we can see it never goes over 1 volt at this feedback pin. So it regulates the current with a maximum value of 40 amperes. This IC has the current sense input. It compares the signal from the current sense resistor with a 1 volt reference. If it is higher than this, then the current cycle is terminated. This is especially useful if you don't want your project to explode. I, for example, use this in my solid-state Tesla coil. Now let's have a look at the datasheet of our control IC, the UC3842. Here you can see that you should use a small RC filter between the sense resistor and the current sense input of the IC to filter switching transients. But because of the high reference voltage of 1 volt, the power dissipation is rather high. To reduce power loss, you can use a lower R-sense resistor in combination with a current amplifier. Setting up the oscillator is even simpler than a 5x5 timer. This RC combination for timing produces a ramp signal. We feed back this ramp signal to the iSense pin to make the signal more stable. For now, our controller doesn't know if there is a short circuit on the output side. It will keep pumping power in the system and our components will overheat. I used the flyback converter as an example, but you can also use a buck converter or a boost converter in peak current mode control. I think you need some time to set your currents, but don't take my schematics for granted. We talked about the topic no one wants to talk about, like I said in the beginning, but let's be honest, was it so bad? I hope you liked this little intro to peak count mode control. If you want to see more, let me hear in the comments and subscribe. Let's see next time at Johnny's desk. Bye. I hope you like Overcurrent protection. Overcurrent protection. The lab power supply. I think you have seen one of these. The current limit. The current limit. Peak current mode control. Peak current mode control. Let's see next time at Johnny's desk.